Semester 2 exam review. The first question's on nuclear energy. These don't require any type of calculation. A particle emitted from a decaying nucleus has a negative. So the key word there is negative charge of one elementary charge, so that's an electron. So the answer is B, a beta particle. Number 2, which type of radiation has the most penetrating power? That's going to be gamma. So the penetrating power always goes alpha, beta, gamma, from weakest to strongest. A sheet of paper may be used to stop the progress of. A sheet of paper can stop alpha. Number 4, which factor associated with radioactive waste has the biggest impact on storage time? So the key word there is time. So what has to do with time? Obviously half-life, because that's the time it takes to decay. Number 5, an atom of uranium-235 splits into nearly 2 equal parts. This is an example of fission, and the key word here is splits. So remember, whenever you're reading any question in any class, always look for that key word. Number 6, which process is the source of the sun's energy? So the energy from the sun is thermonuclear fusion, and the answer there is D. Okay, now we're going to move on to the problems from magnetism. So number 7, as you're reading the problem, it's probably easier to write down the given. During the semester exam, you're going to have the formula sheet. In the back is going to be your scrap paper, so I would actually put it next to the test like this, just like I'm showing you. So it says, in a mass spectrometer, the strength of the magnetic field, so I'm going to write my given. So B is equal to 1.0 times 10 to the negative 1 Tesla. Upon entering the chamber of the spectrometer, the positive ion traveling at, so meters per second, that's the speed, perpendicular to the magnetic field, experiences a magnetic force, so F is equal to 3.2 times 10 to the negative 14 newtons. So now it says, what's the charge? So I want to find Q. So first I'm going to write my basic equation. B is equal to F over QV. I'm going to rearrange the equation to solve for the unknown terms of the known. So Q is equal to F over BV. And then I'll substitute in my values and solve. So this comes out to be B 1.6 times 10 to the negative 19 coulombs. And you can do that yourself on your calculator, because remember, you should have already done this review sheet first. All right, number 8 is also a calculation. So it says an electron, so we have to remember that an electron has a charge of negative 1.6 times 10 to the negative 19 coulombs. It moves at 3.0, so that's V, 3.0 times 10 to the 7 meters per second, perpendicularly to a magnetic field that has a flux density of 2 Teslas. So that means that B is equal to 2 Teslas. What is the magnitude of the force? So now I want to find F. So again, I'm using my equation. B is equal to F over QV. And I'm going to rearrange the equation and say F is equal to BQV. And then I'll substitute in my values and solve. And when I do that, F comes out to be 9.6 times 10 to the negative 12, which is choice C. Remember, when you view this video, this should be after you've already done the review sheet yourself. Okay, number 9, an electron current. So this shows the flow of the electrons. Now this is where we're going to use our right-hand rules. What I do is, remember that there's 2 things you need to remember. You need to remember that the flow of electrons is in the direction opposite of the conventional current. So conventional current is I, and then the flow of electrons is a little E. These go in opposite directions. Now these particular pictures show the flow of electrons. What I do is, instead of using my right hand, I use my left hand. Okay? So the thumb is going to be the direction of the current, but in this case it's the flow of electrons. So pretend this is the wire. What I'm going to do is I'm going to put my thumb like this, and the thumb goes in the direction of the electrons, and then the fingers go in the direction of the field. So which way are my fingers going? They're wrapping around this way, which is choice D. If you just say conventional current is going in the opposite direction, then you would use your right hand. So the choice is yours. I just personally prefer to use the left. All right, let's move on to the next field. So all of these have to do with practicing our rules. So number 10, electrons are flowing in a conductor as shown in the diagram at right. What is the direction of the magnetic field at point P? So again, I'm going to use my left hand, so the thumb is going to go in the direction of the current. And if you look at my hand, this part is going in, and where my fingers are is coming out, like this. Now, if I drew it with the convention that we showed, that's going in and this is coming out, we see that it's coming out at point P, so that is out of the page, D. Number 11, which diagram best illustrates the direction of the magnetic field between unlike? So again, when you're reading this, you're going to look for a key word that's going to make a difference for the review sheet. So this is unlike. So we know that unlike charges, poles attract one another. So we need to know unlike is attract. And the other thing we need to know is it always goes from north to south when we look at the directions of the arrow. So the one that's doing both of those is going to be choice B. Number 12, in the diagram above, what is the direction of the magnetic field at point P? So there's a couple of things we have to look at when we look at this. These are this is north and north. So we're going to have here with north and north, we're going to have them repel. Then the other thing we have to remember is number 2, because this is north, we're going to remember that the field goes out. So let's say I pretended to draw the field. I'm going to know part B. It's going to end up going like this. Okay? So now when it says in the diagram above, it's actually below. What is the direction of the magnetic field at point P? So because it's going like this, it's going to be like this. So the answer is going to be towards B. Because if I had one like this, it's going to be, like that. Okay, number 13. Which diagram best represents the magnetic field between two magnetic north poles? So remember, north poles are going to repel one another, and they're going to come out because it's north, so the answer is going to be A. The field around permanent magnet is caused by the motion of, the only thing that moves is electrons. Number 15, electrons flow in a loop wire as shown in the diagram. What is the direction of the magnetic field at point A? So I'm going to do the same thing. I'm going to, again, take my left hand, except this is a wire. I'm going to, wrap my hand around it, where my thumb is going in the direction, my left hand, of the electron flow. So when I do that, and I don't have a wire here, but if it was the wire, it's going like this. So it's coming out here, and then it's going in here. So the answer is going to be out of the paper. Number 16. The diagram at right represents a conductor carrying a current in which the electron flows from left to right. The conductor is located in a magnetic field which is directed into the page. Okay, so I'm going to take my left thumb here, and this orientation is the one where it's three-dimensional. So you have what? You have your current, okay? You have your force, and then you also have your field. So if I put my thumb this way, and then I put my fingers like this, I'm going to see that the palm is down. So if I'm actually this orientation, it's hard to show on this video. Here's the fingers going into the page, right? Here's my thumb going this way, so my palm is actually pointing towards the bottom of the page. Okay? So the answer is D. And we did a lot of practice of this when we were doing magnetism. Okay, number 17. Okay, so now we're into circuits. So it says base your answers on this. So there's two questions for this one diagram. So first of all, the first thing I'm going to do is when I look at a circuit, I'm going to say there's no combination circuits on the test. It's either series or parallel. So the first thing I'm going to say to myself is it series or is it parallel? So this is parallel. So that's the first thing I need to know. So the first question says the equivalent resistance. So remember that resistors that are in parallel, 1 over RT is equal to 1 over R1 plus 1 over R2 plus 1 over R3. So this one, the numbers are easy. So this I might be able to do in my head, 1/4 plus 1/6 plus 1/10. Some of you like to do it on your calculator. I'd like to find a common denominator because this way I know I don't make a mistake. When I add up the numbers and do this, I get 62 over 120. Now, the biggest mistake is that people make 1 over RT is equal to 62 over 120. RT is not equal to 62. Remember, you're going to cross multiply, so RT is 120 over 62, which on your calculator is 1.4, which comes out to be about 2. So this answer is B. Number 18, the current R1 is, so I want to find the current going through this resistor. So remember, I can apply Ohm's law to an entire circuit, or I can apply Ohm's law to one branch in the circuit. Now, the first thing I'm going to say is, for R1, I know R1 is 4 ohms. Well, what else do I know? Well, the next thing I'm going to do is I'm going to ask myself, what's the same in parallel? So what's the same in parallel is the voltage. So if this is 30 volts, that means this is 30 volts, this is 30 volts, and this is 30 volts. So V1 is equal to 30 volts. So now I'm going to apply Ohm's law, and I'm going to say V is equal to IR. So I is equal to V over R, which is 30 over 4, which comes out to be 7.5. And these are easy enough I can do in my head, and that's how all these are going to be on the test. All right, the next two go with the next diagram. So the first thing I'm going to say to myself is it's series or parallel. So this is series. How do I know it's series? Because I see that from the source, the same current is flowing through all the resistors. So it says, what is the reading of V2? Well, you have to read this question. They actually tell you that the current is 2 amps. So because they're in series, the current's the same everything. So it's 2 amps throughout. Oh, it says, what is the voltage? So V2, I'm going to apply Ohm's law. So V2 is equal to I2 times R2. So it's going to be 2 amps times 4 ohms, which is 8 volts. Number 20, what is the total resistance of the circuit? So in series, RT is equal to R1 plus R2 plus R3, which is equal to 4 plus 3 plus 6, which would be 13. And again, you can do this in your head. So these circuits on the test are a lot easier than actually what we did in class, because we're not doing combinations. All right, number 21. It says the reading of ammeter A2 is, so then when I go back and look at that, remember it's all the same, and we already knew that, so it's B 2 amps. If additional resistances are added in series and the applied voltage is kept constant, the reading of the voltmeter, this is going to decrease, because remember in series the voltages add up, the current remains the same. Number 23, what I'm going to do is the first thing I'm going to say is it series or parallel? This one's parallel. So number 23 says, what is the effective resistance? So for parallel, 1 over RT is equal to 1 over 60 plus 1 over 40. I would just easily find a common denominator. 2 over 120 plus 3 over 120 is 5 over 120. So RT is equal to 120 over 5, which reduces to 24, which would be choice C. Number 24, the reading of ammeter A1. So remember, this is parallel, which means the voltage is the same. So if this is 120 volts, This is 120 volt. This is 120 volt. I can use Ohm's law. I is equal to V over R. So 120 divided by 60 is equal to 2. Compare the current in ammeter A3. The sum of the currents it's going to be the same because in parallel the voltages add up. Number 26, if a third resistor is connected in parallel, the total resistance, now this is going to decrease. Now if you look at the equation, if you need to visualize this, so if I have 1 over RT, now I have 1 over R1 plus 1 over R2 plus 1 over R3. Okay. So if I add another resistor, it's going to be less. All right. Number 27. Now we're back to static electricity. So here we see we have a picture of an electroscope. Which diagram shows the leads of the electroscope charged negatively by induction? So there's two key words here. Number 1 is negatively. Number 2 is induction, because we need to know the difference whether I bring the charged rod close to the knob or am I touching the knob. Okay? So in this case, induction means I'm not touching it. I'm bringing it close. So any one where it's touching, I'm going to eliminate those choices because induction does not mean touching. So now I'm already down to 2 choices. So now it says that the negatively charged, well, that one's positive. So the answer here is B. So this is actually easier than it appears. Number 27, I think we actually did this in class with a balloon where somebody rubbed it on their head. So it shows a balloon. So how does the balloon stick to the wall? Is C. Okay, number 29. When hair is combed with a hard rubber comb, the hair becomes... Well, first of all, you're going to say to yourself, what's the only thing that moves? Electrons. So the electrons are the only thing that moves. So right away I'm crossing off the protons ones. So the electrons are the only ones that move, so it's going to be removes the electrons from the hair. Number 30, in the charging of a solid, charge transfer is accomplished by the displacement of, again, the only thing that moves is electrons. Number 31, in the diagram below, a negatively charged rod approaches a neutral pith ball. In which direction does the pith ball first move? Well, this is neutral, so it's going to be attracted to this negatively charged rod, which has an excess of electrons, so it's going to move that way, which is A. Oh, I wrote the answer in the wrong place. Whoops. I didn't read this question yet. Which procedure will double the force between 2-point charges? So F is equal to K Q1 Q2 over R squared is Coulomb's law. You could look at it and it says which procedure will double the force. So I want this to be double. So in order for this to be double, something in the numerator has to be doubled. Or something in the denominator would have to be halved or something, but then this also has squared, so they're not even going to make it that hard. So something here needs to be doubled, so that'll be choice B, doubling the magnitude of one charge. Okay, number 33. Which diagram best illustrates the electric field around unlike charges? So remember that going out of the negative, going into the positive, so that's going to be D. I mean, we know unlike charges attract one another, but then you also, so there's 2 things you have to look for as far as the arrows, which way they go. So you see, we haven't had that many problems thus far, so these go quick. Number 34, if 20 joules of work, so work is equal to 20 joules, is done in transferring 5 coulombs of charge, so Q is equal to 5 coulombs, between 2 points, the potential difference, V, is, So this is the equation. V is equal to delta PE over Q. So work is equal to the change in energy. So when they tell us the work is 20 joules, that's equal to delta PE. So V is equal to 20 joules divided by 5 coulombs. 20 divided by 5 is 4. Number 35, 1 coulomb per second, that's the definition of an amp. Number 36, as the temperature of a coil of copper wire increases its electrical resistance. So the resistance means that it's impeding the flow of electrons. Okay. So remember, there's 4 factors that influence a wire. So temperature is 1, diameter, and the others. All right, so now we have another circuit in here. So first I'm going to say what type of circuit is it. It's parallel. Okay. They also tell us when you read it that the combined resistance is 6, so RT is equal to 6. So it says the current R2 is equal to. So they gave us RT, but they didn't give us R2. So I'm going to write over 1 over RT is equal to 1 over R1 plus 1 over R2. But now I want to find R2. So 1 over 10 plus 1 over R2 is equal to 6 ohms. Or 1 over 6. So 1 over 6 is equal to 1 over 10 plus 1 over R2. Now, remember with fractions, you have to have a common denominator. So 1/6 minus 1/10 is equal to 1 over R2. What I did was I found the common denominator, which is 60. And when you do that, so you have 10 over 60 minus 6 over 60 is 4 over 60. And so R2 comes out to be 15, which would be 60 over 4. Number 38. An ammeter reads, so now I'm going to use Ohm's law. So when I do Ohm's law, V is equal to IR, I is equal to V over R, so 30 divided by 6 is equal to 5. Most of the math for the circuits you can obviously do in your head. What is the power? So remember, power is equal to V squared over R, so it's just 30 squared divided by 10, so the power is 90. Number 40, compared to the potential difference. Remember, potential difference is the voltage across the source. The potential difference is the same. How do I know it's the same? Because in parallel, V is the same. Number 41, if the resistance of R2 was increased, the current through R2 would decrease. Okay? So remember, V is equal to IR, so I is equal to V over R. All right. Series. So we have one more circuit. This one is a series. In series, the current's the same. The current through R1 will be, well, the total current here is 4. The answer is 4. There's no calculation. All you need to know is that in a series circuit, the current is the same. Number 43, the voltage drop across at R1 will be, so remember in series, the voltage adds up to the source, so it has to be less. So those are our first 43 questions, and then we'll do 44 through 90 on the next one.